Hello, good evening, everyone. I'm one of the TAs, course TAs for the Natural Language Processing NPTEL course, and today we'll be discussing some practice problems from the week one's content. Um, so I'll just wait for a few minutes for everybody to join in, and then we'll get started. Meanwhile, could anybody just confirm whether the screen is visible? Like I'm sharing a presentation, is it visible to everyone?
It's visible now.
Okay, thank you. Okay, we'll get started. Again, good evening, everyone. Welcome to the live session. Just to introduce myself, I'm one of the TAs for the NPTL course, NPTL Natural Language Processing course. And like now, week one's content has been released. I hope all of you have gone through the same. And we'll be discussing some practice problems from there. So, we'll start with this problem. So in the first problem, we'll be discussing the problems. I would also encourage you all to give in your inputs, as in how to solve the problem, what are your intuitions regarding the problem, and we'll keep it interactive and we'll keep solving the problems. So the first problem is, okay, just confirming one thing. Hope I'm audible to everyone, right? Please just give a confirmation once.
Yes, ma'am, you are audible.
Okay. So in the first problem, what we will be discussing is, so in a corpus, it is found that a word with rank 4th has frequency 600. What can be the best guess for the rank of a word with frequency 300? So would anybody like to approach the problem? Otherwise, I'll go ahead with the solution. Or would anybody among you like to approach this problem? Or should I wait for a minute so that you all can also try? Maybe I'll just wait for a minute so that you can try the problem and then I'll go ahead with the solution.
Is it eight?
Yes, it's correct. So how did you, what are the principles that you used in solving the problem?
The frequency 600 has rank only 4, so 300 is half of it, maybe. So the rank doubles.
Okay, yes, it's correct. So the law governing our solution is the Zipf's law. So what does the Zipf's law state? It states that the frequency of a word and its rank in the corpus, they're inversely proportional. In other words, if you take the product of the frequency and the rank, it would result in a constant. So similarly, so we use the values that are provided in the problem statement. So 600, so it is given that a word with frequency 600 has rank 4. So we take the product of 600 cross 4 and that should equate 300 cross R. From here, we get the rank of the word with frequency 300 should be 8. So I hope everybody could solve the problem. If anybody has a doubt, you could unmute yourselves and you can ask. Okay. Okay, I hope nobody has a problem. Okay. We'll go over to the next question. In case people have doubt, you can feel free to, rather than posting in the chat, you can unmute yourselves and ask at any point. So our next question is, you're given this sentence: in Kolkata, I took my hat off, but I can't put it back on. So here, so this is a very fundamental question. We need to answer what are the total number of word tokens and word types that are present in this sentence. Again, I would request all of you to try the question once, to give in your inputs, and we'll discuss the problem in maybe in 1 minute's time. So those of you who just joined the meeting, we are solving practice problems from week one's content. So we are currently solving this problem. So kindly try the problem once, and we'll be discussing the how to approach the problem in a minute. So we're trying to work on the solution, and we'll approach it like as soon. Yeah, correct. Roshan is correct. Would you like to unmute yourself and give and tell what are what tokens and what types? Um, okay, fine. Um, I'll go ahead with the explanation of the problem. So, we know that as the professor taught in the lectures, what are types? Types are concepts. So, they are unique instances of the words that occur in the corpus, whereas tokens are all the instances, not necessarily unique, all the possible instances of the word in the corpus. So from there, we can see that the total number of unique words in the sentence are 13, whereas the total number of tokens is 14 because the word I is repeated. I is repeated here and here. So that is one duplication that is present. Rest all the words in the sentence are unique. So that gives us the answer of 14 and 3. So okay, so Abha is asking that what is the answer of question 1? So we can go back to the question once. So answer of the question is 8 in question 1. Here we are using the Zipf's law. Just to reiterate briefly, we are using the Zipf's law, which states that the frequency of a word is inversely proportional to the rank of the word in the corpus. And as a result, the product would be a constant, and that from that, using this principles, we are deriving the answer. Is that okay, Abha? I hope I'm audible to everyone. Not getting any response. Okay, fine. Thank you. Um, Anybody has any doubt in the question number 2? It's a easy but a fundamental question. So if anybody has any doubt, you can ask, or else I'll go ahead. Any doubts in question 2? All right then. We'll go to the next question.
Ma'am,
Yes,
Ma'am, can you explain again?
sure. Which question should I? Question number 2?
Yes, ma'am.
Okay, sure. So see here the sentence that is given to us is in Kolkata I took my hat off but I can't put it back on. This is the sentence that is given to us, and what is asked is we have to tell what are the total number of word tokens and word types. So how we approach this problem is we first need to understand what is the difference between token and type. So as discussed by professor in the video lectures, types are nothing but concepts. They are unique instances of the word that are present in the sentence or the corpus, whereas tokens would be all possible instances, not necessarily unique ones, all possible instances of the word in the corpus. So here if we see this sentence that in Kolkata I took my hat off but I can put it back on, here we can see that I'm counting the number of unique words, okay? This is in is 1, 2, 3, 4, 5, 6, 7, 8, then I is repeated. So I'm not counting that. 9, 10, 11, 12, 13. Okay, so total 13 unique words are there, and that accounts for the number of types. Okay, but we saw that I is repeated twice. So if I now count the total number of words in the sentence, which would be 14, that gives you the number of tokens. That is the count of tokens. So here the number of count of tokens would be 14, and the number of word types would be 13. Does that clear your doubt? Or you can ask if there's any specific concern. So I did not catch the name of the person who asked the question. So just tell me if you could understand what I explained, or else I can repeat it. No, I can repeat it again. Is your doubt cleared? Um, yes, somebody has unmuted. Is your doubt clear? Did you ask the question?
Yes, ma'am. Ma'am, my question is also this, but
Yes.
I cleared.
Okay, okay. You're cleared. Okay, fine. Since I'm not getting any response from the person who asked the question, I hope you have understood it. Otherwise, you can put it in the chat, or I'll move ahead meantime. We can come back to this question again. Okay. Feel free to ask questions. I'll be happy to explain it again. Okay. We'll move on to the next question. So now the question is, so let the rank of two words be W1 and W2 in a corpus be 1600 and 400 respectively, and M1 and M2 are the number of meanings of the words. Now, what would be the ratio of M1 is to M2? Please try solving the problem. I'll give you 1 or 2 minutes and then we'll discuss the approach of solving the problem. Okay, I think some people have solved the problem. Um, So I would again request if anybody from any of the students who have solved the problem want to put out their point. How did they solve the problem? What principles they followed? You can unmute and you can speak. Okay, okay, fine. So so here again we are using this law which correlates the number of meanings and word frequency. So here the law says that the number of meanings of a word is directly proportional to the square root of the frequency. It means the more frequent the word is, the more possible meanings the word can have. And how is the relation? It's proportional to the square root of the frequency. Okay. And now if we consider the rank, because I think in the problem the ranks are given, right? We need to the ranks of the words are given. So now if we use the law, so this is so here we can see that so the number of meanings would be inversely proportional to the square root of the rank. From where we can just plug in the values now. So m1 by m2 would be square root of the ranks that are given, rank 2 by square root of rank 1, and that gives the answer of 1:2. I think some people posted the solution in the chat as well. So anybody has a doubt in this problem? I hope are people being able to solve the problems? How about, and like if anybody has a doubt in this problem, please feel free to ask. Okay. Some people just joined the live session. So, so we are solving problems from practice problems from week one's content, and this was the last problem that we solved. You all can also solve this parallelly. I'll move on to the fourth question, but if anybody has a doubt, that the people who recently just joined the call, the live session, they can like ask meanwhile while we solve the next question. So this is a question. This is an easy question. So question 4 is, what is the valid range of type token ratio of any text corpus? These are the options. Um, so what would be the answer? This is again a very fundamental question. So I think I'll just okay. Rito Broto says it's option 1. How about others? There are 28 people in the call. I would like everybody to like try solving the problems. Okay, Vibhor also says it's option 1. Samyukta says option 1. Okay. How about others? Roshan also okay. Okay. Yeah, okay. Chalo, okay, we'll move on to the solution now. So yes, like most of you got the answer correct. It's option 1. So so in a corpus, the number of unique words or the number of types would be less than or equal to the number of tokens in the text. And since both of them are greater than 1, so that would give us the value of what do we call the first option. So here one thing to note that when so the equality happens when all the words in the sentence or all the words in the corpus are unique. In that case, the number of types and the number of tokens would be same, and in that case, we'll get a value of 1. And if there's a like so 0 won't happen. So 0, it's open. You cannot have the value 0 because if there's at least one word, that would be an unique word, and in that case, we'll have some ratio at least. Okay. So this is question number 4. Okay, let's move on to question number 5. So here, okay, so here here it is given that I hope nobody had problem in the last question. I won't just keep on asking, but if anybody has, you can feel free to ask. So here it says that the first corpus has a TTR value of 0.025, the second has a value of 0.25. So we need to say, like, we need to comment on the sentences that are given. So we have certain sentences given, which of them are true, which of them are correct, we have to say. So please take a minute or two to think about the problem, and then we'll discuss about it. Okay, Akarshita, Roshan, and Adnan has said it's option 2. I also like to see what answers others are getting. Let's wait for one more minute. Ashwini is also saying option 2. That's just 4 out of 27 people. How about others?
Option one is the answer, I guess.
Why do you think option 1 is the answer? I'm just asking for explanation.
Because this first corpus has more tendency to use different words. The ratio is less over there.
Hmm.
So if the number of unique tokens, the types are more over there. So it has more different words.
So in type token ratio, in the numerator we have the number of types, and in the denominator we have the number of tokens, right? So more the number of types, the higher
Types
would
are okay.
the higher would be the value of TTR.
Okay. Types are the numerator.
Yes. So more the unique words.
Then second.
Yeah. Okay. Yeah, that's correct. So so again, the intuition is that when we are calculating the type token ratio, when we see a higher type token ratio, that means the number of we keep on encountering unique words as we go through the corpus, and that results in a higher count of number of types. And so the number of types and the number of tokens would have a comparable count. It would be the number of types would be closer to the number of tokens, and that would result in a higher type token ratio. Whereas if the type token ratio is less, that would mean that there are lots of words that are being repeated in the sentence or in the corpus, and because of that, the type token ratio would be lesser. As the number of unique words it's less, the number of tokens, number of types would be less, but the number of so the overall type token ratio would be less. So that is the solution. um, okay. Okay, we move on to question number 6. So here again we have a set of 4 statements, and here we'll be discussing that which of these are true for English. Okay, so Vaishnavi has said that option 2, the outputs of lemmatization and stemming of the same word might differ. Would you give an example where this might be the case? You can unmute yourself and try if you would like. How about Ashwini? You have said the answers are B and C. Would you like to comment on why you think these are the correct answers?
Yes, ma'am, but examples actually, as per the video I gone through, what professor has given, so depend upon that, I have given the answer. But if you ask me real time example, I don't know. Sorry, ma'am.
Okay, no problem. Could you tell me what is like just not example, but what would be a fundamental difference between lemmatization and stemming? Yes. Any just could you just explain in a line what is lemmatization? Maybe it's fine. It's just I mean, just I'm understanding. I'm just trying to ask the like that the understanding of lemmatization and stemming is crucial to answering this question, right? So that is why.
Lemmatization is nothing but uh, using the proper vocabulary. No?
Okay. And
Stemming, I forgot now.
okay,
Confusion.
okay. Okay, no problem. Thank you.
Thank
Um,
you.
so Vaishnavi has given an example. So, for example, the word caring, lemmatization will give us care, whereas stemming will give us car. Yes, correct. I was just hoping if anybody of you could explain the problem also. Or how about Vijay? I'm sorry, I'm not able to pronounce the name. Vijay Shin Vansadia.
Ma'am, if in stemming, if the word is displayed, then it will remove the I, and in lemmatization, it will give the word proper word display.
Okay,
Or if in case of happy, it will the last part. If the last is Y, then it will remove in one case, and in one case it gives the proper word for it.
okay, okay. So which is the case where it's giving the proper word and where it would be improper?
If happily is the word,
Huh.
then it will be HA double means last Y part will be removed,
Hmm.
uh,
Removed as
and
a result of lemmatization or stemming? Which one?
in lemmatization,
Okay,
and in stemming it will be returned a happy word.
okay, okay, okay. Um, yeah,
Ma'am, you can call me Vijay.
okay. Thank you. Anybody else also would like to join in this conversation and give their insights to this problem?
I know about the stemming part.
Yes, please go on. Please explain.
I think the stemming is a process that removes the last few characters of the word,
Yeah, correct. Oh,
and lemmatization I can do about.
okay, no problem, no problem. We'll be anyways discussing it. Um, okay. Okay, Samyukta says options 1, 2, and 3. Okay, so Samyukta, would you like to also just give your points? Like, why do you think? So we were discussing about 2 and 3 till now, right? Why you think option 1 is correct? Ma'am, can you explain about morphemes? Yeah, sure. I'll explain about morphemes. Um,
Yeah, I assume that in derivational morphemes,
hmm,
I think uh, if you have a word which has a prefix and a suffix,
hmm,
so I think it's something related to the derivational morphemes. So a word is changed by adding a suffix and a prefix. So in stemming, you chop off the border words so that you get the main word. When it comes to lemmatization, I think I'm not exactly sure, but it changes the meaning. Sorry, it adds something to the word so that it fits in correctly according to the rules of grammar. Um, so in lemmatization, I think a dictionary is used so that you cross check whether the word is in its original form or not. Whereas in stemming, I don't think a dictionary is used. I don't think it's like that.
Okay.
This is my understanding.
Okay. Yeah, it's correct. Um, so Vaishnavi has asked me to explain about morphemes. So I'll quickly take up that question. So, so in morphemes or in morphology, so there are two main. So morphology is the process of study of how words are formed in different languages, and two very important word formation mechanisms are inflectional morphology and derivational morphology, which those concepts are used in the first question, first option, sorry. So what is inflectional morphology? I'll explain with an example. Like you have the word tree, right, in English, and the plural form of the word tree is trees. You simply add a suffix s, and that changes the word from a singular to plural form. This is an example of inflectional morphology. What happens in inflectional morphology is after you add the suffix or a prefix, there's no major change in the meaning of the word. So the word tree means a single tree, whereas the word trees means one or more trees, right? The underlying concept remains the same. Moreover, what happens in inflectional morphology is that the category, the part of speech category of the word after the word formation process remains unchanged. So here when we see the word tree and trees, both of them are nouns, right? Only one is a singular form and the other one is a plural form. Now, if we talk about derivational morphology, an example would be uh, yes, an example of derivational morphology would be that of say, just a second. Yeah, so it would be say write and writer. Okay. So here we see, so this is an example of derivational morphology. Just observe very carefully that when I say write, it means the action of writing, whereas writer is the agent who's performing the action. Writer is the person who is writing. There's a change in meaning when the suffix r is added. Okay, this is usually observed in derivation morphology, and also you observe that there's a change in part of speech tag. Write would be is a verb, whereas writer is a noun, right? So like these are the fundamental differences between inflection and derivation morphology. I just explained it because I think one of you asked. So here and what would be morphemes? So morphemes are the units that form the word. For example, take the word unbreakable. Okay, so this is a word which constitutes of three morphemes: un, break, and able. Okay, here un, which comes before in the beginning, that is the prefix. Able is the suffix, whereas the word break, that is the root of the word. So here three morphemes, three morphological units are forming the final word, which is unbreakable. So that is what morphemes are un, break, and able, suffix as well as the root. So all of these things forms the morpheme. So I think Vaishnavi had asked the question, was I able to explain? Um, so yeah, so okay. Yeah, so now I think I'll move on to the solution. Yeah, so as we can see here, so stemming, what happens in stemming is it's just a crude heuristic process that chops off the ends of the words. Okay. In the hope of achieving this goal correctly, where and often includes the removal of. I'm just reading the answer. You all can also read. I'm just This is the solutions I was reading. Whereas lemmatization is, you as one of you suggested, it includes the use of a vocabulary and morphological analysis of words. And here you derive the head. Lemmatization, you derive the lemma or the head. So as you can see over here, change, changing, changes, change, changer, here all of them have the lemma, root word that is constituting all the words is change, and that is what would result as a like when you perform lemmatization, you obtain the lemma, which would be change, which is a meaningful unit. Okay, whereas when you perform stemming, you're just abruptly chopping off the last few characters, as it says that it's a crude heuristic process. Okay, just simply like abruptly chops off a few characters at the end, and it's not necessary that you'll get a meaningful word. As for example, you get chang, which is not a valid word in English as a result of stemming. So options 2 and 3 would be correct over here. And there's no distinguish, like on some of one of you also said option 1. So here lemmatization is not like, so it's removing the like the inflectional ending. So because of that, like option 1 would not be correct. So yeah. So question 7. So here we'll be discussing about an advantage of porous lemma over a full morphological parser. There are different options given, and so, yeah. So please take a few minutes and okay. Some answers have started coming in. Ashwini has said option A. You can like explain your point. When Aniket has said option A. Yeah, go on.
Ma'am, here I selected one because uh, here the suffixes will be removed. Example, as sir explained in the video, like a place. If example is place, so we will it will be play.
Okay.
So I thought first one would be the answer. So and the one more example which I explained in the video, pony. So the output will be pony, poni. ES will be removed. So suffixes will be removed. And the example walking, there will be two words which we will get walk as well as sting also. Sting will remain as one word only.
Okay.
So these are the notices which I.
Okay. 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 Great. Um, how about I think next Roshan has said 1 and 3 maybe. Okay. So Roshan, why do you think 1 and 3 are the answers? Please unmute and you can say what were you thinking? Um, okay. How about Aniket? Aniket also thinks it's option 1. So same as Ashwini. Aniket and Ashwini are agreeing. How Ritobroto has said option 3. So Ritobroto, why do you think it's option 3?
Ma'am, for a stammer, there is no need of a vocabulary or a dictionary. It just randomly chops words.
Yes, so it does not. Okay.
So that's why it is an advantage, I guess.
Okay, and then how would you justify this? You're saying option three is correct and the rest are incorrect, right? Like rest are a
Yes,
disadvantage. So
yes, ma'am.
yeah, so how about option two? Why is that a disadvantage? Or why is that not a point to agree on?
Because it is not always a valid word,
Hmm,
output of a stammer.
right, right. Okay. Um, okay, still just four people has answered. We will wait a few more minutes. Please, others also try. Please put in your answers in the chat. We'll wait for a few more minutes. Only four, five people have answered out of 28.
Ma'am,
Yes.
ma'am, can you explain the meaning of lexicon, which is present in option three?
Yeah, so lexicon would be sort of a dictionary. Dictionary, like
Okay,
we, like growing up, we used to refer to dictionaries to understand meaning of words, right? So, so it's from a high level, that is what a lexicon would be, a dictionary containing words.
okay. Thank you, ma'am.
Okay. So, still it's like just seven people who have answered. So, how about the other 21 people? Please join in. Please join in the problem solving that we're doing. Please try solving the problem. This is also like a theoretical question, so you can just read the question and you can try answering it. Like whether it's correct or not, that's irrelevant. We are just trying to solve problems. It's not an exam, so please put in your answers as well. We'll try figuring out what is the right answer. Okay, Vaishnavi has made a good point. So she's saying that she thinks that option 1 and 3 are correct because full morphological parser analyzes the word complexity, including its root, word, verb, parts of speech, etc., mainly useful for lemmatization. Whereas stemmer does not require all that information; it just stems the suffix. So yeah, which is okay. Yeah. Okay, I think we'll move on to the solution. So the answer in this case would only be 3. So I'll just read the solution once and then we'll discuss further. So it says that the Porter-Stemmer algorithm, okay, which was I think discussed in like elaborately in the videos, in the lectures, that Porter-Stemmer algorithm is a process for removing suffixes from words in English. The Porter-Stemmer algorithm was made on the assumption that we do not have a stem dictionary lexicon and that the purpose of the task is to improve information retrieval performance. So, stemming algorithms are typically rule based. You can view them as a heuristic process that sort of loops off the ends of words. So, here one term is information retrieval. Information retrieval is it's I think it hasn't like it's information retrieval. You can understand from what the word means. So you're retrieving information from somewhere. So maybe given a passage, you want to find out what are the main keywords or what is the main content. So information retrieval is in itself a huge huge part of natural language processing where there are like their entire research work going on over there. I won't be able to explain it in a few lines, but from a high level, it is like as I explained. So that is why. So I think from the solution, you can understand that. So option 3 would be the correct answer in this case. Okay. I think many of you had also suggested option 3, right? So I think many of you were thinking on the right track. Some people had also suggested 1. So I think now you understand why 1 would not be a proper answer. Okay. Um, so now we move on to question number 8. Which says that which of the following are instances of stemming as per Porter's stemma? You have to go by the rules or heuristics that are there in Porter's stemma, and you have to say which of these are instances of stemming. Okay, that's some people have put their answers. Vaishnavi, Ritobroto, Ashwini, Vivor, Roshan. Okay, Shubhodeep, Samyukta, and Vijay. Okay, so let's start with the Vivor this time. Vivor thinks the answers are 2, 3, and 4. So, would you like to explain why you think the answers are 2, 3, and 4?
Yes, ma'am.
Yes.
So as we have discussed previously, ma'am, तो हमारा basically प्रीफिक्स को कट कर देता है, काउंट कर देता है, तो प्लेस को वो प्ले कर देगा और सो को वो एज अ वर्ब काउंट करके ए डब्ल्यू जो प्रीफिक्स होंगे
I think thoda connection. I think there's a bit of a connection issue. Could you please repeat once more?
तभी आई
Are others able to hear what Vibhor is saying?
No, ma'am.
Okay.
Your voice is audible, but his voice is breaking.
Okay, okay. So Vibhor, could you, acha, Vibhor left the meeting. I think he'll rejoin. Let's see. Yeah, Vibhor has joined again. Yes, Vibhor, go on.
यस मैम सो एज आई वाज सेइंग मैम कि हमने जैसे पहले भी इसको डिस्कस करा था मैम तो ये हमारा प्रीफिक्सेस को कट डाउन कर देता है और ये सेंस हमारे वर्ड की बात में बने या ना बने उस पर ध्यान नहीं देता है तो फिर प्लेस को ये प्ले कर देगा और सो को ये एक वर्ब लेके उसको एस में कन्वर्ट कर देगा और यूनिवर्सिटी का आईटी बाय प्रीफिक्स हटा कर यूनिवर्स कर देगा
अच्छा, 100 का आपको क्यों लग रहा है? Why do you think option 3 is valid? Just explain a little bit more. Like it's cutting out most of the word, right? Only one character is remaining at the end, right? I'm just asking, just intuitively asking. What do you think?
मैम क्योंकि अगर हम इसको ऐसे ही रखते हैं तो ये काइंड ऑफ लेमेटाइजर की तरह हो जाएगा मैम क्योंकि वो इसको एक उसमें कन्वर्ट कर देता है मीनिंगफुल एक्सट्रैक्ट
Acha. Okay. Okay. Let's see. How about Shubhodeep? Shubhodeep thinks it's option 2 and 4. Would you also like to explain? So everybody is sure that 1 is not the answer. I know it's pretty obvious. Just they like you can also explain like Shubhodeep, would you like to explain your solution and why you think option 1 and 3 are incorrect? Somebody has unmuted themselves. Mm, Hello. Yes, Shubhodeep, would you like to explain? You're you're not audible. No, you're not still audible. Yeah, yeah. Go on. Yeah. No, no, no. You're not audible. Shubhodeep, you're not audible. Um, it's fine. I think there's some issue with the audio. You're not audible. Um, fine. Let's see if like okay. So maybe let's Samyukta. How about Samyukta? Would you like to say? You think option 2 and 4 are correct, right? So could you please explain?
Yeah, I'm actually sure of option 2 and 4. And the third one, SAWS, I'm not really sure if in the photostemma, in the list of suffixes, whether AW is a part of it. The sole reason I mentioned 2 and 4 is because I'm not sure of the third option.
Okay. What
I don't
about
know.
okay? What about the first option though?
First option, I think it's an example of lemmatization. It goes back to the root word.
Yeah. Okay.
So that's not. I'm
Okay.
not sure of 3.
Okay. Okay. Um, let's see. Maybe we'll take a one more person. Okay, how about Vijay also thinks it's 2 and 4. Just let's hear what Vijay has to say and then we'll go on to discussing the solution. Vijay, could you tell?
For the first option, it's root. If given the root word, it will come in the case of the lemmatization. So, and stemming it will not give the root word.
No.
For the third, I am not sure, so that's why I
Okay. 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 Vaishnavi thinks that it cannot, I think it cannot be 1 and 4 because they're too short for stemming. Okay. Um, okay. Okay. Fine.
Ma'am, I think the
Hmm.
third one, saw, is also the part of stemming.
Okay. Why do you think so? What is the, I mean, okay, why do you
Ma'am,
think so? I mean, yeah.
as we know, the saw stemming is involves the removing the suffix from the original word. So here in the saw word, O, A or AW is the part of suffix. So we remove the O part, so it's remain the S part. I think so. Saw is also the part of instance of stem.
Okay. Okay. Um, okay, fine. I think we will discuss the official solution once. So it's actually 2 and 4. So just a second. So I'll just read. So for stemming, many people said option 1 is incorrect, which is true. So stemming cannot convert R to B, as it can only convert a chop of word suffixes. Also, now why 3 is not the correct answer? Porter stemmer wouldn't chop off the final outcome is of length 1, as we saw in saw to saw. So there's a constraint on the length that prevents option 3 from being a valid answer. So this is as per the rules. So this is a rule in Porter stemmer, which because of which this conversion cannot take place. Okay. Okay. Let's go on to the next question then. So this is option 9. What is natural language processing good for? This is a very of application based question of natural language processing. So please try this question.
Excuse me, ma'am.
Yes.
I'm sorry for the questioning the last question, but
Yes.
for my satisfaction, I rechecked on the chat GPT. So
Okay.
it says the saw is also the part of stemming according the portal stemming.
So ChatGPT does not always give reliable solutions. Okay, it can hallucinate a lot of times. So here, one thing that I can say is that, like if you think in terms of morphology as well, like we were discussing morphology a while back, right? So if you see saw is the past tense of see, right? And here,
Yes,
I mean, so here if you see, it's not like it has, so it has completely transformed, right? So see to saw, it's not like s is a like, it's it's abruptly, it's like, it's not like there's a head or a morpheme or a key morphing that is governing this. Okay, so it's a stemming operation for sure. Maybe because of that, maybe ChatGPT has said that, because you see there's a stemming operation for sure that is going here, right? You're abruptly like cutting off the last few words, um, but like as far as I know, that there is a length constraint. If the length constraint was not there in Porter stemma, then this could have been an example of stemming. But just because the length constraint exists in Porter stemma, this would be the limitation. Okay. Yes. Okay, and in this question 9, everybody agrees that it's the option 4. So all of the above is the answer. So let me see how many people have answered. 7, 8, okay, 9, 10, okay. People are answering. Okay, good. Please keep on answering. I mean, it's great if all of you engage in the live session. Um, so maybe we can discuss this one also. I think it's good if we interact. So let's see. Adnan is I think Adnan hasn't discussed before. So maybe would you like to just briefly? I know this is like this is an obvious answer, but still, like, would you like to just briefly state like why do you think option 4 is correct, and why do you think that natural language processing has all these applications? And if have you ever witnessed, like when you're using daily applications in your day-to-day life, where have you seen natural language processing? We can extend the question and even we can discuss that. So please join in. So Adnan, would you like to put forward your what your thoughts were? Or like you can even like let aside this question, we can also talk like what, like daily day to day in day to day life, where have you come across natural language processing? I think we use it everywhere nowadays. Like given with Chat GPT, let aside leaving Chat GPT, where have you observed like application of natural language processing? Okay, Adnan is not responding. How about Ritobroto?
Ma'am, Chat GPT, Google
Leaving Chat
Bard,
GPT, leaving Chat,
then
just day to day
even
life.
simple Google search,
Yeah, okay. And
it can identify the type of entity. It's- Then the AI assistants, all those.
okay, okay. How about Aniket? Like more simpler things also, not like not leave out Chat
ma'am,
GPT. Yeah, go on.
the applications of natural language processing, as we use the Google Assistant in Android, in Apple we use Siri, in Amazon we use Alexa.
Mm-hmm.
That's
Okay,
the basic examples of natural language processing application.
okay, okay. Vaishnavi has suggested.
And
Yeah, go on. Yeah, go on. Go on. Yes, go on.
autopilot cars also can be the example of NLP.
Autopilot cars, I think they come more into the domain of vision. I think computer vision. Um, but yeah, that is also like comes under the domain of AI/ML. So I mean, um, makes sense. So Vaishnavi has said keyboard autocorrect, auto suggest and autocorrect. Yes, that is like something we encounter. Like whenever we are chatting or typing, we see like automatically suggestions made by the keyboard and all. So that is there. How about others? I mean, Richu, would you like to say? Like there are many options, and I don't think we'll run out of options. So anything else would you like to add, Richu? Richu Shibu. Yeah.
Yes, ma'am. I also think using this ChatGPT or BART or BERT models also support this, which supports this natural language processing. They do all this summarization, then extraction of keywords and all. We can tune those models to do all these tasks,
Okay.
which are
Okay.
based on NLP.
Okay. How about how many of you have used like Grammarly or Quillbot for writing, and like how many of you have used that, right? That would also be an people have raised hands. Okay. Yeah, go on. Three people have. Achha, okay. So you all have used Grammarly. Okay. So that is also like an example of natural language processing. Um, so there are many things actually, many places that these are being natural language processing is being used. Also, like as you all as one of the points is mentioned and mentioned in the answer, and you all also mentioned like summarization is which yeah, news summarization, or even just giving a text, or giving like this. I think ChatGPT does very well, right? That if we give a huge block of text, it is very good at summarizing. So all these things are there. So summarization and information retrieval, many things that that the natural language processing can do. Okay, I think we'll Amazon summaries. Samyukta is saying Amazon summarizes user reviews, thus reducing the effort of reading reviews of all the users. Yeah, that is also one more application that given a review, say um, you have bought something new from Amazon or Flipkart, and you have given a review, or when you're reading reviews as well, you see those would be categorized. Say you have bought a camera, it would come under, so it would have different features, maybe the lens, or what is the focus, and what everything. So based on that, based on different aspects of the review, so extracting the aspects, even giving a number to it, all those things. Like that is a review sort of that is also a part of natural language processing. Text cortex is also good at AI application, mainly in NLP. So Vaishnavi is saying that text cortex is also good at AI application, mainly focusing in NLP. Okay. Okay. um Great. Okay. uh Great, maybe we'll go on to the next question. So yeah, the right answer is option 4, all of the above tasks, which we already discussed. Now, question 10, which is like, what is the size of unique words in a document where the total number of words is 12,000, K is given, and beta is given? The 4 people have answered till now. Let's wait for 2 more minutes. I think more people would also, like, it's given us a numerical problem. Let's wait for 2 more minutes and then we'll discuss. Okay, let's discuss the problem. Let's see. So Ashwini answered the question first. Let's Ashwini, could
Yes,
you?
ma'am.
Yeah.
Ma'am, this answer I got on the basis of the formula, that is k multiplied with the total number of words to the power of beta value, that is 0.69, which we get the option of first one, that is 2421.
Okay, and what is the law? The name of the law? Could you recollect?
Law name,
Oh,
Gibbs law, ma'am.
yeah. Right.
Yes.
So yeah, the solution that you gave, it's correct.
Yeah,
Uh,
I used that formula, ma'am. Basically, I used that formula and I got the answer. So we're trying to tell.
yeah, right. That is the way. That is the way to solve this problem.
Yeah.
So yeah. Just maybe one more person maybe will take, and I mean it would be a bit repetitive, but let's hear what I think maybe let's see. Like, Vibhor maybe could you tell? Mm, Vibhor, are you there? Then okay, fine. I think so. I think we'll go with the solution. So, like as correctly said, so this is the Heaps law, which correlates the vocabulary and the number of tokens. So, so this is the formula governing it, and as like the entire figure was put by someone in the chat. I think Roshan or yeah, Aniket put it, and even Roshan. Both of you had put the formulation out there, and this is correct. So, like most of you got it correct. So this is the correct solution. So, so this was the last practice problem for today, but I think we have time till 9, so we can discuss like other like lectures or lecture doubts or lecture contents if anything you want to discuss. So please feel free to ask.
Ma'am, if you don't mind, can you please go back to that third question, ma'am? I have a confusion regarding that answer based on that formula. What was there?
Yeah, sure. This one?
Yes, ma'am. Yes, ma'am.
Yeah. So here you see, so there are two words given, right? W1 and W2, and the ranks are 1600 and 400. Okay.
Yes, ma'am.
And meanings are like there could be multiple meanings associated with a single word, right? Even the
Yes.
professor said in the lectures. And so what would be the ratio of the number of meanings that these words can have? So how do we go about the problem? This also has like a formula or a principle governing it. So here the number of meanings of a word is directly proportional to the square root of its frequency. Okay.
Okay.
So it means the more frequent a word is, the more number of meanings it would have. So that would be the intuition to think about it. Okay. So the more rarer a word it is mostly the case that it would have a unique meaning associated with it. Okay. The more common or more frequent the word, the more number of meanings. Okay. Now we already know that frequency and rank are inversely related. We just plug that in and we get that m would be proportional to 1 by root r. So now they share an inverse proportional relation. Because in our problem, rank is given and we are asked to give the ratio of the meaning. So that is why we needed this form. Okay. So here from here now we can say m1 by m2, which is the quantity that we need to compute. That would be the square root of rank 2, square root of the rank of the second word divided by square root of rank of the first word, and that gives us square root of 400 by square root of 1600, and so this is the answer, 1:2. So is it clear now?
Yes, ma'am.
Okay. Acha, I think there are ones some people has.
हेलो
Yes.
मैम आई थिंक ये आपने फर्स्ट वीक का डिस्कस किया जीरो वीक का शायद डिस्कस करना था
Zeroth Vika is it's for just it's not part of the course content, so that is why I didn't take it up today. It is like just for practice and for knowledge of the students. So if yeah, so these one second. I think I gave asking these 10 questions the practice problems are the graded assignment due on 7th. No, these are just practice problems. These are just practice those problems based on week one's content. They are not based on any questions that are there in the course. The questions that are there in the course, those you have to solve on your own. These are just to enhance your understanding. You graded. Okay. I think Dr. Gayatri Devi has said, can you please summarize this week's lectures? I mean, the lectures, they contain a lot of things. I would be happy to summarize, but I mean, given the huge content, I cannot take all the content up. If there's something specific that you want me to discuss, I would open the lecture slides and I'll discuss. So could you please tell if there's any specific part that you want me to, or any specific lecture that you want me to go through, and I'll discuss. Yeah, okay. Samyukta is saying, could you please explain the concept of rank in Zipf's law? Yes, sure. I think one thing I can do is I can open the lecture slides maybe. I think that would be helpful. Just a second. I'll share the lecture slides one second. So it's taking a bit of a time and meanwhile discuss. So Samhita was asking what is the idea of rank, right? Could you please explain the concept of rank? So rank is so you basically take so you would have a corpus, right? In that corpus, you count the frequency of each word type in the corpus, and based on that, you would be listing the words. So here we consider the unique words. Okay. So given a for large corpus, given a corpus, we first find out what are the unique words in the corpus. Then for each unique word, for each word type, we compute its frequency. Okay. So now what we have at hand, we have word type and its corresponding frequency. Now based on the frequency, we arrange the word types in decreasing order. Okay. Now if we do that, that would give us a ranking of words. The most frequent word would be at the top and the least frequent word would be at the bottom. So that is what you mean by ranking.
I wanted to know how the number is assigned, the rank, because is it just 1, 2, 3 based on which appears more frequently, or there's some formula, right? F into R is equal to K. So what is K?
K would be a constant. K is simply a constant. So that is an empirical law. So here you won't like find so rank would be 1, 2, 3, 4 only. Okay.
Okay. For the higher rank,
Yeah.
the
So
last number.
yes. Now I shared the lecture slide. Probably I hope it's visible, right?
Yes. On page 8, I was on page 8. I was looking at that.
Okay. 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 So
And there's an example, the 50th common words. I don't understand.
50th common word. Could you? Where
Yeah,
is it?
yeah. On page 8.
Page 8. Okay. Page 8 is this for me. Um, Is it the example where it's 50th common word and 150th common word? The 15th common word would have 3 times the frequency, that one?
Yes, exactly the same thing.
Okay. So I don't know where it is, but I'll explain.
Probably 98, maybe if you type 98.
I got it. Yeah. So this one you're saying, no? That's the 50.
Yes.
So what you see over here is so the 50th common word means the corresponding word has rank 50, right? So W1, say we have two words, W1 and W2. W1 has rank 50, whereas W2 has rank 150. Okay.
Okay.
Now we are thinking in terms of what would be their frequency. Okay. So one thing to remember here is that when a word has higher rank, it's inevitable that that word would have a higher frequency. I'm just saying for intuition purpose, I'm saying that. Now to give a more mathematical statement,
Okay.
here we can see that this f into r is a constant. Why is that? Because Zipf's law says that the frequency and the rank would be inversely proportional.
Hmm.
Right.
Good.
So if so the 50th most common word would, if it has 3 times more frequency, then and only then it would equate the rank of the other. So 50 into 3 3 times k would be 50 into 150 into k, right? Where k is some common constant.
50 into
I mean,
3.
say,
So
yeah,
considering 50 as R,
yeah.
okay, and
Frequency is 3 times, it's saying, right? So,
yes,
so the ratio is 3 is to 1, right? For that, so 3 is to 1 is if one has 3k frequency, the other would have k. So 3k is to 3. It means 3 is to 1, 9 is to 3. Like that, I'm saying, where k can take any arbitrary value. Like that, I was saying.
okay, so the k remains constant. So the 50th common word will occur with 3 times the frequency of the 150th most common.
Yes.
So, yeah,
Um,
yeah, because k remains constant. So,
yeah.
yeah, so that appears 3 times more than the 150th
Yes. Yes.
common. Okay, yeah, yeah, got it.
Okay.
Thank you.
Yeah, sure. Okay. Um, Anybody else has any other doubts? Um, Doubts and questions?
Ma'am,
Yeah.
ma'am, can you please explain Heaps law?
Yeah, sure. Just a second. I'll open it up in the slides.
It's 112.
Yeah. Yeah. Okay. So here, one thing that I think could be a cause of confusion is corpus. So what is a corpus? Corpus is just a uh, huge text file. Maybe you can think of like that. Maybe a Sherlock Holmes novel or something. Just giving an example. So a huge quantity of text. So that is what corpus is. And now we are asking that how would you correlate the size of the overall vocabulary? Okay, what and vocabulary of any language is, it's fixed, is the number of unique words that are there in the language. So maybe, so for English, there's a certain number of unique words that you will find in the language. For Hindi, there's a certain number of unique words. Like that, for every language there exists a certain number of valid unique words that constitutes the vocabulary of that language. Okay, so that, and the size of that set would be the size of the overall vocabulary. So here in Heaps law, we are trying to correlate the size of the overall vocabulary, that is the number of unique words, and how does it relate to the size of the corpus. So what does Heap law says here? This means modulus V means the size of the vocabulary, and N is the number of tokens. Okay, and the relation is the size of the vocabulary would be k times n to the power beta. So the commonly observed value of k so would be between 10 to 100, and for beta it would be between 0.4 to 0.6. These are all like, so so this has been observed in practice, and from there these values, empirical values, has been extracted, that what would be a typical value of k and beta. And now we see here we are getting a relation between the size of the vocabulary and the number of tokens that are present in the corpus. Um, um, is it clear now?
Yes, ma'am.
Okay.
Ma'am,
Yes.
ma'am,
Yes. Yes.
ma'am, suppose we have a corpus of a very large text
Yes.
quantity, huge text quantity.
Yes.
We have a corpus, right?
Hmm.
So how we get to know the value of k in that?
So value of k would be like, you won't be able to know an exact value. Okay. So here here the, like, the corpus is variable, right? You can take any corpus, right? And there you cannot say beforehand that this would be the number of tokens. So what this law would give you is an approximate count, estimation of what could be the number of tokens, not the exact number of tokens that you will be observing in the corpus. And that is why you have a range from 0 to 100. You have to plug in these values, and when you plug in these values, you see more or less this is giving a count which is resembling the actual count of the corpus. Does that make sense?
Yes, ma'am.
Okay. Could you please explain the example of Zipf's law MNR, page 106? This one?
Yes, that the means the example of what we could teach.
The empirical support.
Yes, yes.
So empirical support is these are just a second. So these are things that has been observed in experiments and all. So this is not like a direct evaluation. That is not something that you put in the formula and you got this. These are empirical evidences that um that coincide with the results of the law as well. Okay. So empirical means the source is from an experimental setup. So I think maybe some corpus, I think maybe it has been taken from, maybe the empirical evaluation from Tom Sawyer was done, right? So here maybe if you see the word with rank 10,000, which is, if is it given here? Rank with word 10,000. It's not here, but it's like generally you can observe that it would have about two meanings. And if you take a word with rank, say 2000, it would have higher number of meanings, maybe approximately 4.6. Rank with
Okay,
2000.
so this is specific to a certain text, certain corpus.
Yes, yes, yes.
It's not something that you, like you said, plug into a formula.
No, no, no,
You
no.
need a sample, and based on that, these are the results.
Yeah, these are like empirical support. Yeah, empirical support means these are evidences from the experiments that is supporting the principle that has been given by the law.
Okay. So
Yeah.
what has been conducted on? There is some sample on which the experiments have been conducted. What kind of text?
This one, I am actually not sure on what this was conducted on. Okay, but in the previous slide, the evaluation I think has been conducted on Tom's Ware from.
Okay, in the same slide, I have one more question.
Yeah,
In
yeah.
the rank, same thing.
This one.
Table, yeah. So we have in the rank, we have 1, 2, 3, and then we directly jump to 10 and 20. So that was the reason I had a confusion regarding that. So
Oh,
I do think some are missing in these, so they have directly jumped to 10, 20, because the numbers are not continuous, the rank.
yeah, I don't think like, no, I think those are the only examples that I picked up. So I think the main objective of this slide was to show the product of FNR is more or less the same. I think the
Okay, so there is also, there are also words with rank 4, 5, 6, 7, 8, but they are not shown in this table.
yes, yes,
Oh, thank you. Thank you.
yes. So everybody can ask doubts, anything that they have, they had issue in understanding. Maybe I can go over that. Or in general, if you have any questions, I'm happy to answer. So the live session will continue till 9. So we have for 20 more minutes, so we can discuss. Let's see, any particular topic, which were the most difficult topics that you found in these week's lectures? Maybe we can discuss that. And yeah, somebody had unmuted.
Um,
Yeah,
word segmentation
what said?
1061.
Okay, okay, yeah, okay. So I think Chinese is, so this is for Chinese, right? So um, greedy algorithm for Chinese specifically. So the Chinese,
I want to know about the Sanskrit one in the next page.
okay, sentences. This is like more of a, how can I say? This is more of a mathematical description. So let's discuss. Okay, so first the text segmentation procedure. Here we are taking an assumption. The assumption is that class sentences from classical Sanskrit may be generated by a regular expression R of the clean closure W star of a regular set W of words of a finite alphabet sigma. So this is like a general assumption. Then, okay, so here again, you see, so Sanskrit is a inflectional language. So we were discussing about inflection and derivation and morphology, right? So Sanskrit is a very inflectional language. So you'll observe many words which are inflected in Sanskrit. So here, that is why we are taking vocabulary of inflected words of padas, and R would be the sandhi. Sandhi would be the conjugated form of the word. So we have sandhis in like other in our native languages as well, right? Sandhi would be like let me think of an example. Um, One second. Like sandhi is you take two words, and I think you know the example of sandhi. I'm not able to remember right now. Does anybody remember an example of sandhi right now? I'm not able to recollect. Um, Please feel free to unmute and say if you remember an example of sandhi.
Like Vidya or Alaya, that's called Vidyalaya. That is the
Ha ha.
example.
Yeah. Right. Correct. So that is an example of sandhi. So now, given these two things, given W and R, how do we analyze a sentence? A candidate sentence W is analyzed by inverting relation R to produce a finite sequence of word forms. Okay, together with a proof that W belongs to R of W1 dot W2 dot W1. Okay, so I think there would be an example. This is mathematical, so I think maybe that is why. Let's see. So this was a sentence that was originally given. Okay. And now this is the, I think the transliterated form, I think, or the phonemic form. I think, yeah. So then, so this, as you see, this is the same sentence in English. So this is a transliterated version of the Sanskrit sentence. And from there, you're taking in chunks. As you can see, you took Satyam, then you took Bruyat, then you took Priyam. Like that you're taking, and you're checking whether they're valid word forms or not. So in Sanskrit, the valid word form, as we saw here, so it consists of inflected word form. So padas in Sanskrit would be mostly like verbs and nouns constitute like the inflected word forms in Sanskrit. So those are the things which, so inflection would in Sanskrit would be for multiple cases. Like in English, we also see inflection for number and case. As we were talking, like number, we see singular, plural. That could be a cause of inflection. Even gender. So in languages like Hindi and Sanskrit, gender in unlike English, these languages also have an inflection for gender. So given the word, you can understand whether the speaker is a male or a female. So all these things are taken into account at the time of inflection. Okay, and other things as well. So that is that even tense is a form of inflection. All these things account. So given that, from that you this is more of a like you're checking each of the instances. So once you find a valid word, you again start from that point and you find what is the next valid word, and like that you keep on iteratively moving the pointer, and whenever you find a valid word, valid inflected word form, you stick with that, and like that you find the entire possible word sequence. Yeah. Mm, so Nadul is asking, will we get recorded live sessions on YouTube? Yeah, so the sessions are being recorded. You'll get, and they would be uploaded in YouTube as well. Yeah.
Ma'am, I have one doubt.
Yes.
Ma'am, this discussion sessions will happen every Saturday, ma'am, or once yesterday or I think 2 days before we received the email for problem solving session. So after we received first assignment, we got this email. So like this, after we get week two content, and then after a week we will get again problem solving sessions, ma'am.
Yes, yes, yes. So
So once we receive the email, and we have to join through that link for the particular whenever we get, like today example.
yes, yes, yes.
Okay, okay.
I think there are multiple live sessions that are being conducted for this course. I think 3 live sessions. So today I am taking,
Yes,
I think there are 2 more. So,
tomorrow is there, and then Tuesday is also there.
okay, 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 okay. Like that, weekly, after each week, we'll be discussing problems related to that week's content.
Content. Okay, okay.
Yes,
Thank you.
yes. So Chaitra is asking whether tomorrow's sessions will be on the same set of questions or different. So I'm actually not aware of the. I'm not aware of that.
Ma'am, every Saturday sessions will be taken by you, or how, ma'am?
Yes, yes. Every Saturday I'll be taking the sessions.
Okay.
Okay. So will Madhul is asking, will there be any coding part? Um, I mean, given like if there's any coding related to the content, then there will. Otherwise, there will not be. I mean, I'm also not aware. As and when the content, like every week's content gets released, I'll also check. And if there is any, we can. Will we get recorded live session? Yeah. So as I said, so this session is being recorded, and it would be uploaded on YouTube. And I think all of you would get links to the YouTube video as well. So you can check that also. So not right now. The YouTube link would be shared by the NPTEL team themselves. I'm just seeing it would be available on YouTube. So yeah, we still have time today. Still have 9 more minutes. Please ask questions, doubts. How are you? And I hope you all are enjoying the course. You're finding the course interesting. Um,
It's more of confusion, ma'am.
okay.
Interesting also it is there, but more of confusion. When it comes to videos, after the videos were uploaded, we watched the videos one after the other since it was a presentation. And when we saw this assignment content, so totally it was a confusion. And since today you solved, it was more helpful actually. So I had done particularly two, three mistakes in the answers. So
Okay.
that was clear for me actually.
Oh,
Because the third one which I told, I did it actually like a W1 by W2 as per in the video, or sorry, W2 by W1, something like that. I got different answer. First one, second one, I believe.
okay, okay.
So like it's more of confusion actually. How
Oh,
to come out from this confusion one, because as we see the video, that explanation, everything we will understand at that moment. So when it comes to this numerical MCQs, here there is a lot of confusion.
okay. I think that is very natural. I mean, if I was in your position learning these things for the first time, I would also have the same confusion. Is that now I've read it like a couple of times. Now I'm like okay with it. So more practice problems you practice. Try attending all the live sessions. I mean, everybody would be discussing
Yes,
problems.
ma'am.
So I think that would be very helpful. And
Ma'am,
like
actually for the exams we will have a MCQ pattern, ma'am, or
I am actually not aware of the that.
okay,
Yes, yes. But
okay,
mostly I think it would be MCQ. NPTEL exams are usually of that sort, but I'm not the official person to give the
okay, okay. No, no,
info.
I just asked you, ma'am, that's all. Because since the assignment was like this, MCQ part, so because if it is like that, then it will be easy since we are all discussing and sharing our thoughts and thinking everything. So it will be easy if it is like in the same pattern. Otherwise, we have to study some other notes like in engineering, how we are doing now.
Okay.
Like that.
Okay, okay. I understand. Okay, yeah. I think it would be MCQ only. So, and by the end of the course, so you all would be very like you'll be experts, so no problem.
Yes,
Mm.
hopefully, ma'am.
Yes, yes. No worries on that.
Yeah.
Uh, Mustafa says that in case of foreigner students, can we take the final exam somehow? Please contact the NPTEL team. I don't know about these like administrative queries. Please drop a mail to the NPTEL team. They'll surely help you out. So, Sir had told in his very first lecture that there will be. Okay, okay. Mridul is saying that. Okay, I mean, okay. If there is, then at the right time we would be discussing those as well. I'm also like going with you guys only with respect to the course content. Wherever that comes up, we'll surely take it up. I hope that that's okay, Mridul. Yeah, the recording will be available. So then the recording will be available. Yeah, we still have few more minutes. People can still ask their doubts. So I think this week's content was mostly the most important part. I think the empirical laws are very important. That is a very important. Like if I say in long-term perspective, the empirical laws are good. They're very intuitive and they would be helpful as well if you're planning to work on NLP. So please go through that and. Also, like, so the initial few lectures, they are very foundational. So try to like, and also as you can see, there are many here as I was going through the slides, you see different languages are being discussed. It's not English, so the more languages that you come across in India, also we have so many native languages, right? Over 600, 700 languages only in India itself. So each language has its own characteristics, own properties, and it's very important to be clear with the foundations. Um, so please go through all these lectures, all these slides, try practicing problems. If you have any more doubts, like we can discuss now, or next week again, next Saturday we would be again having a session. We can take it up there also. So if somebody has unmuted,
No, no, myself only. I just thought thank you and have a great weekend.
thank.
So another 2 minutes, so we will end the session.
Yeah, yeah. Oh, thank you so much. Same to you. Same to you. Same to everyone. Happy learning and happy weekend. Yeah, thank you. Thank you so much. Yes, thank you, everyone. Thank you, everyone. Thank you for joining. We would be closing the session now. Thank you, everyone.